All right, last class we talked about graphing quadratics that were in vertex form, and that's this equation here with your A, H, and K, and you talk about your different transformations and your vertex. Today we're going to still be graphing, but this time we're going to be graphing equations that are given to us in standard form. So the standard form is anything we see where we have ax squared plus bx plus c. The way to tell the difference between the two is vertex form will always have your parentheses inside them. Your standard form will have a term that's squared, a term with just an x and a coefficient, and then your constant term. So before we go on and talk about how to graph, given this equation, we need to talk about different pieces of our quadratic. We talked a little bit about this last time, but this point down here, this is your vertex. Your vertex is always going to be the middle of your graph. Everything else is always going to be built around the vertex. So finding the vertex is very important. This graph here follows the pattern of over one, up one, as you see with these two dots here. But if you look over at this blue one, this is also, just like in a line, our y-intercept. We didn't talk much about y-intercepts last class because they don't play a huge role when you have your standard form, your vertex form. However, in standard form, our y-intercept is going to be a pretty big deal. The last thing we need to highlight is our line of symmetry. So our line of symmetry, again, I talked a bit about it last time, but it's this imaginary dotted line I write, and it's kind of like the mirror. So we've said everything is based around your vertex. So no matter what side of the line I'm on, if you notice, this point over here is also mirrored on the other side. This point would be here. That's also mirrored on this side. So each sides of that imaginary line would be the same. So again, that's called our line of symmetry. And notice, since it's a vertical line that goes through your vertex, that's always going to share the same x value as your vertex. So looking at standard form, again, it's the ax squared plus bx plus c, and we have a couple short steps to getting a graph from the standard form. Step number one is I'm always going to label a, b, and c, because I need to know those three numbers to be able to figure out everything else. Step two is I'm going to look at A. If A is positive, my graph is going to open up or smile. And if A is negative, then the quadratic is going to open down or frown. So for here, A is still going to tell us whether our graph opens up or down. Step three, we want to find our vertex and our line of symmetry. The way we do that is we find the x value by using the equation opposite of b, so I'm going to put a negative sign there to show opposite, all over 2a. Once I have that, I'm going to take the answer, so this would be like 3a, or the second part of 3. Once you have your x value, you're going to take the answer and plug it into the original equation. And the reason we do that is because if you have an x value, you plug it into the equation, that will give you your y value. So that's where we get our entire vertex from. So we have whether it should open up or down, and I have my vertex. To have a full quadratic, I need to have 3 points. So my second point after my vertex is very simple. That's going to be my y-intercept. And my y-intercept is your constant term, so that's going to be 0 and c. So whatever is by itself, doesn't have an x squared or an x with it. That's going to be your y-intercept. Last but not least, step 5. Remember I talked about that line of symmetry, and I said everything that happened on one side has to happen to the other. So I'm going to take my y-intercept and reflect it over your line of symmetry. And that's going to give you your third point. So here's our first example. Graph the quadratic using its vertex, your y-intercept, and another point. And remember, this other point is going to be the y-intercept reflected over your axis or your line of symmetry. So step 1 is to label a, b, and c. A is always my term with x squared, so that's 2. B is always your term with the plane x, so that's negative 8. And c is your constant, which is 6. So step 1 is label a, b, and c. Step 2 is I'm going to know here that since a is a positive 2, that tells me that my graph is going to open up. Next is finding our vertex. So remember, I'm going to use that equation, x equals the opposite of b all over 2a. Since b is negative 8, I'm going to put the opposite of negative 8 in there, which is positive 8, all over 2 times a, which is also 2. So you can either plug all this into your calculator at once or work it out one step at a time. I'm not going to do anything with 8 yet, but I know that 2 times 2 is 4. And in this problem, 8 divided by 2 is 2. So the x value for my vertex is 2. So I'm going to use that to figure out the y value. So I'm going to take 2 and plug that into the equation. And again, from this point, you can either plug it into the equation, plug it into your calculator, or figure it out one step at a time. So I know here that 2 squared is 4, and 2 times 4 is 8. Negative 8 times 2 is negative 16, and then I add my 6 here. So 8 minus 16 is negative 8, and plus 6 is negative 2. So my vertex is going to be the point 2, which I got up here, and then my y value is negative 2, which came from right here. So I'm going to go over to my graph, and I'm going to graph the point 2, negative 2. The way I get my second point is I know my y-intercept is the c value. So here my y-intercept is the point 0, 6. So I'm going to go all the way up to 6. And last but not least, I have my line of symmetry here. Since up here I have a point that is 2 left to the line of symmetry, 2 to the right of the line of symmetry, I know that I have to have another point that mirrors it on this side. And that's how I'm going to get my U-shaped. Now, if you don't like doing that using your y-intercept, I just think that's a really easy point to work from. Another thing you can do, and I'm going to make this a little bit bigger so you guys can see, is from here you can still follow your pattern of up 1 over 1. I'm saying things I don't know. Example number 2 is very similar. It says graph the quadratic using your vertex, your y-intercept, and one other point. So I'm going to start again with labeling A, B, and C. This time A is negative 1/2, B is positive 2, and C is 3. So I'm going to look at my A value. A is negative. So that tells me this time that my graph is going to open down. Because remember, if you're negative, you are going to frown. After this, we're going to start by finding our vertex, again using the equation x equals the opposite of b all over 2a to get me what my x value for my vertex is. So I'm going to have x equals, and then I have to write in the opposite of b. This time, since b is positive 2, the opposite of that is negative 2, all over 2 times a, which is negative 1/2. Again, you can plug this directly into a calculator or just work it out a piece at a time. So the top is still going to stay negative 2, but the bottom is 2 times negative 1/2. So this is taking half of 2, which is just negative 1. Negative 2 divided by negative 1 is positive 2. So again, that's the x value for my vertex. Once I have the x value of my vertex, I'm going to take the original equation, and in place of x, I'm going to write what it equals. So again, I use the regular equation. In place of x, I put in the x value of my vertex, which is 2. Working this out one step at a time, I have 2 squared, which is 4, and 4 times negative 1/2 is negative 2. 2 times 2 is 4, and then I bring down this 3. So negative 2 plus 4 plus 3 is 5. So my vertex is the point 2 and 5. So I'll go ahead and graph that. From here, I can just look for my y-intercept. My y-intercept is my c value, which in this equation we said that c is 3. So I'm going to write that my y-intercept is the point 0, 3. And if you also remember, we said that our quadratic was supposed to open down. It's supposed to frown. So the fact that our y-intercept is below our vertex is perfect. If I look at my line of symmetry going through my vertex, I have a point again that is 2 to the left of my vertex. So I need to mirror that on the other side and have a point that is 2 to the right. So now that I have my 3 points, I can go ahead and sketch in my quadratic. So that is the steps you need to follow. First, labeling A, B, and C. Figure out whether A is negative or positive. Using the equation x equals negative b all over 2a to find your x value for your vertex, then plugging that answer into the equation for the y value. Once you have your vertex, you just need to graph your y-intercept and then reflect it on the other side of the vertex. So you need to follow on this very last problem. So again, try on your own, graph the quadratic using its vertex, y-intercept, and another point, and your equation is g of x equals 2x squared minus 4x minus 1. Good luck.